This video is going to be about hypothesis testing when there's a single sample, and we'll be addressing means. Sample means being used to either make statements about population means or confidence intervals to estimate population means. So what I'm going to do is I'm actually going to do a couple of problems from your homework, and I think that will be a good way to show how you can do these tests in StatCrunch. So let's read the problem here. It says, what are the chances your flight will leave on time? To the right, we have the summary stats for the percentage of flights departing on time for each month from 2001 through 2006. Is there any evidence of a trend over time? So I've saved you the trouble of responding yes, yes, yes to all parts of A. Part B wants a 90% confidence interval for the flights that depart on time. Well, I know once we get into StatCrunch, they're going to ask us for some of those summary stats. So I'm going to jot down N is 72, that the mean, the sample mean is 80.3472, and the sample standard deviation is 2.75862. Now, since they want this rounded to 2 decimal places, I'm not going to be stingy with decimals. I'm going to enter everything I have. So under Get More Help, you can always pick StatCrunch. And under Stat, we're going to pick Summary Stats. Nope, and we're going to pick T-Stats, because for means you use T-Stats. One sample with the summary. We have the summary data here. So the sample mean was, here we go, 80.3472. And the standard deviation was 2.75862. And the sample size was 72. And this particular problem is not a hypothesis test. It's a confidence interval. They want us to establish a 90% confidence interval for the average percent of flights that arrive on time. And there we have it. Okay, this degrees of freedom has to do with when you're using the t-distribution, the degrees of freedom are always 1 less than the sample size. They give you the standard error, and we can talk about that later, and they give you the sample mean, which we entered. Okay, so let's look at the output. They want 2 decimal places, so we're going to jot down 79.81 for lower limit, 80 oh my gosh, that's going to bump that up to a 9. I think it's going to be 80.90 when you do all the bumping up from one decimal spot to the other. Okay, so let's go back to the problem. And we're going to put in 79.81. We can't get to the next part until we answer this part, and then 80.90. 90. Nice work. Okay, what's the last thing here? The last thing, oh, I gotta move this down or something or other. Oh, continue. Haha. Okay, now we have to decide what the conclusion is. I'm looking for the word confident. If I see a statement that says confident, that's good. Chance is not a statistical word. All months is not a statistical word. There's the word chance again. That's not a statistical word. So I think we're going to go with A. We can be 90% confident that the interval contains the true mean percentage of flights that depart on time. If this was a part of an assignment and you had to write your own conclusion, I think that's a little vague. I would say we can definitely start it off with, we are 90% confident that somewhere between 79.81 and 80.90 of the true mean daily functions, mean monthly percentage of plane departures are on time. I think instead of just saying that the mean is, you really should specify exactly what the variable is. Cool. So now we're going to go on to question 3. A marketing firm says that the average 18 to 24-year-old has 649 Facebook friends. But a particular student wants to test if the mean in his high school is higher. Okay, so let's see what the marketing firm says. We better write that down. It's 649. And so the null hypothesis, what are we going to pick? You only pick the null hypothesis that has the equal to sign. A null hypothesis is nothing is happening. I'm not going to contradict the marketing professional. It always has an equal sign. And here comes the alternative, where the student is saying, I don't think that's true. I think the mean is greater than 649. So the alternative can have a greater than, depending upon how the question is phrased. It can have a less than, or it can even have a not equal to. It has 3 options for the alternative, but there's no options for the null hypothesis. Okay, the t-statistic. Well, we're certainly not going to do that by hand. What are we going to do? We're going to go to get more help. And no. We're going to click on the icon to get the data. Okay? Because there's lots of data. Wherever you see an icon, click on it. There are lots of data that this student collected. Now click on this icon to open it in StatCrunch. And look at that. I don't even want to count how many there are. One thing I do want to do is this name. I don't like it. I want to call it Facebook Friends. Then when I see it in the list, it will make more sense to me. So we're going under the stat menu, the T-stats, because we're dealing with means. One sample, there's only one sample. This time it's with data. So where's the data? In that column. What was our null hypothesis? 649. The marketing person thinks the marketing person thinks it's 649. You, however, think that in your school things are different. Okay, it's more than 649. Okay, so that's why it's important to write down before you move on to StatCrunch what the null hypothesis was. Let's compute it. Okay, I'm going to tell you T-stats and Z-stats, it's the same thing. Anytime a T or Z-stat exceeds 3, it's going to be significant. Okay, I think they said at the 0.5 level of significance. So in other words, if the p-value turns out to be less than 0.05, it's significant. What does that mean? It means we are going to reject the null hypothesis. You always go along with the null hypothesis and say, okay, I'll take your word for it. It's 649. And then if you find significant evidence against that, and this is significant evidence, you reject the null hypothesis and go with your alternative. So what are we going to say? We're going to say, start it off with mentioning the variable. In this high school, the mean number of Facebook friends is greater than 649, and then quote your p-value. Announce to people how sure you are, quote your p-value, so they'll know that is a very strong statement that you are making. Okay, so they wanted the T-stat. Got to write that down. So the T was 4.9146, and the p-value is 0.0001. Okay, I think, and it actually gives you the sample mean. Before we leave this, I want to tell you that very often when you find that there is a significant difference, okay, you might want to follow it up with a confidence interval. So you could switch to a 90% confidence interval. Without having to enter anything again. So now we have a confidence interval, and that's powerful. They didn't ask us for it, but who knows? In another situation, they might. 117.08 is the low bound, and the upper bound is 785.90. Always start, I think I've said this before, start a statement about confidence intervals with, we are 90% confident that on average the number of Facebook friends in this high school is somewhere between 717 and 800 and we'll call it 86. And that's the end of the story. You told them that you're 90% confident. You mentioned the variable number of mean high school, mean Facebook friends at this high school is, and then you've mentioned the boundary values. That makes a good confidence interval. So let me see. We're going to get out of StatCrunch, and we're going to get out of this. We're going to be done. And we're going to go back to the problem. And what was our T-stat? It was 4.91. And we're going to check our answer. Cool. And the p-value to 3 decimal points, 0.0001. What? Round to 3 decimal places. Was there an extra 0 in there? I'm annoyed with this. I'm going to show completed. What did they want? Close. I should have put just 0.0000. Oh gosh. So there is significant evidence to conclude that the mean number of Facebook friends at this school is greater than 649. Well, I hope going over these 2 homework problems gives you a good idea that there are 2 possible ways that hypothesis can be tested for population means. One is given the summary stats, and the other is given the raw data. In the raw data, there'll always be an icon for you to open so that you can get it loaded into StatCrunch. And I think we're going to get out of all of this. And is there anything else I wanted to tell you? It's this last little bit here. Just if anybody says to you, what is a confidence interval? You'll tell them, well, point estimates, just giving you the sample mean or the sample proportion, that isn't good enough because it's just one number from an experiment or survey that was done once. We need something better. We need a range of values. That's a confidence interval. 2 numbers that we can hand them and say, the real population mean is between these 2 numbers, and I'm 95 or 99% confident of that. That's the power of a confidence interval over simply, a point estimate. What about hypothesis testing? What are the pieces of the output? How does StatCrunch compute the t-value? You start with the sample mean or sample proportion. There should have been a t-value because it's means, and then you multiply by this quantity. Everything following this, the z and the stuff in parentheses, the standard deviation over the square root of n, everything following the plus or minus sign is called the margin of error. You've heard it in elections, that we favor the favorability for this person is 53% with a margin of error of 3%. That means it could be 3% more, could be 3% less. That's what the margin of error is all about. This little number here, in case it ever comes up in a problem, this is called the standard error. These sample means are floating around. If you're doing a confidence interval, you're taking all of these sample means and you're making a graph of them, and this is the standard deviation of the sample means, and it's called the standard error. One takeaway is the bigger the sample size, the smaller the confidence interval, the more accurate your estimate is going to be. So if you're unhappy with your confidence interval, it's too wide and you want to make it narrower, get more observations. So I hope all of this is food for thought, and looking at two problems was a good idea. I think it was. So replay this video. I'm going to publish it on Canvas, and you can review the mechanics of getting a confidence interval and setting up a hypothesis for studying population means. Okay, hope this helped. See you later.